Awesome. Thank you.
I'm recording it,
All
Alex.
right. What was that?
I'm recording the session.
Awesome. Thank you. All right. So I'm not qualified. I'm just a curious student who wants to show others the many things that I get into. So number two, I will now be getting into the math behind it. You can view sources at the end of the slides for more information. Uh, I feel like if I get into the math right now, it's going to be very tricky and it's going to be really confusing. Uh, so number three, you can view the live editing using this link. So I'll go ahead and share this link in the chat. And you guys can see what I'm going to be working on in my collab notebook. So if you guys can go ahead and click on that, you will have to be using a Maricopa email, your Maricopa email address to be accessing uh, this link. So go ahead and let me know when you guys are ready. At the end, there will be a Q&A, and it's okay if you get confused because it does take time. It does like I'm not even 100% like fully capable of doing some of these, but I am uh, I can understand what's happening behind these in order to tell you guys what's going on. And six, thank you. All right, so we're gonna be this is exact like a visual representation of what we're gonna be doing. We're gonna have a bunch of data. We're gonna be grabbing a few of them, so it's gonna be a written number, and it's called like data, and this is pretty much what it has. It's already prepared. The data is already prepared, so it's kind of cheating. It's not like in the real world where you're gonna have to be preparing your data and making sure there's not gonna be any mistakes when you're doing the training. It's gonna go through the neural net, and then with our PyTorch, it'll be able to make a prediction and classify what kind of number is the handwritten one. Deep learning was created as a subset of machine learning in which the computer mimics the human brain using neural networks. And right here, you can see a neuron. This is pretty much what your brain is using. And these dendrites, which is the outside of these little hair-like structures, is pretty much going on in the neural net, which is going to have all these x values, which is your input. It's going to go through the whole process of the layers, and then it's going to give you an output on what it thinks it is. So the types, we have supervised, which analyzes labeled training data and produces an output, which can be used for mapping new examples. And this is what we're going to be doing because we have labeled data. In our training session, we're going to have data that's it's going to have the image of the handwritten, and then we're going to also have the exact the answer to that, and that's how we're going to be training it. And the semi-supervised, it combines a small amount of labeled data with a large amount of unlabeled data during training, and that's semi-supervised. And then unsupervised, so through mimicry, the machine learns patterns from untagged data. And these are other fields or other parts of deep learning that you can explore. So the process, it does get so every model is kind of pretty much this this kind of process, and it's not going to have the same exact code that we're going to be typing in today, but you will see like a similar design, and you can categorize different parts of a code to understand exactly what it's doing. So first off is prepare the data. Two is design the model. And then we construct the loss and optimizer, and four, we train the model. So this is going to be the full code that we're going to be typing in today. right here on the top, we have prepare the data, where we have a train set and a test set. 2, we have designed the model, and this is pretty much how we're going to be making our hidden layers and what process it's going to go through when it's training. Constructor loss and optimizer, and these are pretty much like the weights, and it's going to be able to, I guess, hello? Sorry, I heard somebody. Uh, and then 4, we're going to be training the model, and that be the last process. So Bree, I know it's pretty, it's just a lot to take in, I believe. And so first off, we're going to be preparing the data, and I'm going to
Alex,
be live coding this. Hello?
Alex,
Yes?
are people able to get in? Because we're getting a message that says, watch for an email access, but then it's not getting sent. So,
Oh, I
if
see. Are
people,
you using the Maricopa email by any chance? If that's not
yes.
working, then I probably
But-
have, I may be having some issues. Let me see if I can.
All right, let me try getting into, okay. All right, so Merrick, oh, I was probably using my CGC. Let me go back and take a look and see, but I could see other people asking, so I will do
Okay,
that.
so I'm gonna go ahead and share another one. It's the same
Okay.
one, but I changed the restriction so anybody with any email can access it. So go ahead and click on it and let me know if you guys can access it. That would be very helpful. So we have somebody says it works. Does it work for anybody else? Yes, it's a blank notebook for now. We're gonna be live. We're gonna be working on it live. So it looks like it does work. So I'll continue. All right. So to prepare the data, this is the most time-consuming part. For this example, we are using pre-made data from the Torch Vision data set. This is not how it works in the world because they said you're gonna have to be preparing the data. This one's already like put into a tensor, which a tensor is just like a matrix. If you ever, it's just like an array, multi-dimensional array. Um, but it's used specifically for PyTorch, so you can read it, and you got like different methods that you can use. Uh, so we're going to be making a train and a test set, and we will use the train set for our model. Then the test, and then we're going to test the model with the test set. So I'll go ahead and paste in all my imports. Hopefully you guys can see this being edited live on your notebook. All right, so we're gonna be going into our data set, and if you can see up here from the Torch Vision library, we're gonna be importing data sets. So we can down here we could just do data sets .mnist, and then we have both our train and our test, and somehow I get an error, which has never happened.
I don't think anyone can see.
Can you guys see on the notebook, like this right here?
We don't see any changes yet.
Hmm.
Yeah, we don't see that, Alex.
Oh, I see. Can you guys see it on this right here in front of the screen?
I can see it in the notebook.
See, I guess I could probably just work on it like this for Do you guys see the screen right now, what I'm presenting?
Yes.
Awesome.
I use that new link that you put in the chat after the other one,
Mhm.
and now I can see it.
Awesome. Yeah, so I'm not exactly sure why I'm getting an error. I'm guessing it's something to do with accessing the internet, but it is connected to the internet, so this is not the way it's supposed to go at all.
Alex, you have a couple of
Yes.
suggestions in the chat you might want to take a look at.
I'll take a look at it. All right, let me read. So somebody's on mobile. Try the new thing. So I'm guessing the new link works. Let me see. I'm trying to test. I'm wondering why it's not working. It's supposed to be going into the data set, and it's supposed to be downloading the information that's on there. But for some reason, it's not letting me access the internet. But I am connected to the internet. I'm sharing presentation. So I guess everybody can see it now, and the new link works. What I'm thinking is I'm taking a lot of bandwidth trying to share this presentation, and it doesn't have enough to download the information for some reason, which is very unfortunate. So I'm is happening because it works otherwise. Okay. I'm gonna wait to see if that works. I'm gonna go ahead and go through the presentation, and hopefully I can give you guys an example towards the end. Okay, so I'll explain what's happening here. We have a train and a data set from the MNIST database. Train, we're going to be setting to true for our train data. What it's supposed to do, it's like supposed to get some random and like shuffle it in order for our training. So our neural network does not learn a pattern that it's not supposed to. Sometimes if you're feeding it like we'll say a 2 in an array in every other batch, and our batch size is 10, it's going to be thinking that every time you pass it 10 batches, or every time you send it 10 different images, it's going to think that the second one is always going to be a 2, and you don't want it to be learning that, so we get to set that one to true. But this only applies for the MNIST in this situation. So the MNIST data set, so for more vision data sets, they can be explored using the following link. I will be pasting these slides after the presentation, so you guys can go ahead and check it out. But essentially, you have images, and these images are going to be a 28 by 28 matrix or a tensor. You can call it a tensor. And it's also going to have a number that with the what it's supposed to be. So like if it's a 2, you're going to have a 2, and that's pretty much what it's going to look like. So to design our model, our neural net, we're going to call it net, and it's a class that inherits from the parent class, the nn.module. This is where using Pytorch, it makes things very easy because it pretty much takes care of everything in the background, and you can just pretty much tell it what kind of neural net you're going to be creating. So we define our layers with FC. You can name it whatever. I just put FC and 1. So our first layer takes an input of 784, and if you can see the animation, hopefully it's not glitchy for you guys, but you can see that it's a 20 by 28 matrix, and so you flatten the image, and it's 784. So our first layer is going to be taking in 784 inputs, which they're all parameters that's going to be created, and then we're going to output 32. You can put whatever numbers you want. If you have like, if you put 64, it could get a better accuracy, but it does take more time and more resources on your computer. So it'd be nice to have a really good computer. So, all right, so the layer takes an input of 784 because our image is 28 by 28 pixels and outputs 32 parameters. And then it's followed by other linear arrays with a given number of parameters, and the last layer outputs 10 because there are 10 different classifications, 0 through 9. So you can see these are our other hidden layers. We have the second one, and it's going to be the same type of linear type of layer, and also our final one is going to be also one that takes 32 and outputs 10. So it's pretty much just going to be going from 784 through 32, and then it's going to input 2, output 32, input 32, and then output 10. So there's other linear layer options, and then there's also other options. It doesn't have to be just linear. But if you do go to the documentation, you will see a handful of different types that you can use for your hidden layers. They all have different types that you're allowed to use. And there's also more info on this link. And of course, you can visit that after the presentation. So the forward function, this is where we're going to be still working on our class, the net class. This is our model. And the second portion, you're pretty much going to have a function that's going to take in some parameters and just pretty much make it go through the array so it can output a number. In our forward, like when you first train it, it's gonna output just some random numbers. Like it's just gonna be like it's not what 4 is until you tell it it's a 4, and then on the next run it's going to be able to understand that, oh, maybe these little pixels in these areas could classify as 4. And so you take it through like many iterations. This can happen like for hundreds of thousands of times or as many as you want, and it could get better at being able to classify these images. So this is for our forward function in our net in our model in our net class. So our forward function will take a parameter which we stated was 784 values for our images. Then we make the values go through our first layer, which makes equal 32 values. So as you can see here, we pretty much call our first layer. It's going to take in X. So pretty much in here, we're going to be passing an image. Once we call this function, we're passing in the image here, which is 784 values. Our first instruction is to call this right here, which is pretty much going to take in the 784, which is our X, and it's going to be doing whatever it does with its hidden layer in a linear hidden layer, and it's going to output some values, just random values, and well, not random, but like whatever the machine wants it to be, and it's going to output 32, and it's going to take it in. Okay, so yeah, it's going to do that. And then we're going to wrap it with the sigmoid function. And so what the sigmoid function is going to do, it's called an activation function, and it'll make those values from a range of 0 to 1. Because you really don't want this to be like over 1. It just makes things easier for the computer to mess with when you're dealing with this. But there is other options for sigmoid. There's a popular one called rectified linear. There's just different types, and I feel like I can't really explain this without getting into the math, but the math is not really what we're going to be covering today. There is a lot of information that you can find online. For the sake of time, there's not much we can really show here. But essentially, it's going to output X, which is this now becomes 32 values because this is what the first layer outputs. So this is pretty much going to output 32 parameters. And now this is going to be put into this layer, which is the second layer that's right here. That's going to take in 32 parameters, which we said this is now 32 because of the first layer outputted 32. And then that's also going to output 32. So now this is 32. For our final layer, it's going to be inputting the 32. And then it's going to output 10. And then we also have a log softmax. And this right here is it's supposed to I did have finally return values and make them go through the log softmax to give probabilities on what the image might be. So this will pretty much, at the end, once you get your 10 parameters, it's going to have different values on whatever prediction it thinks it is. It could be a 0 or a 2 or a 3, whatever number it thinks it is. And the log softmax is just going to be determining what is going to be the final answer of what the machine wants it to be, because it be in different values, all from 0 to 1. And log softmax just makes it so you have a output of what you're going to want. Then we initialize the object. So we set net equal to net. And so this is pretty much is going to be our object that we're going to be using, which is our model. All right, now we construct the loss and the optimizer. So in this portion, we're going to be using cross entropy loss as our loss function. It's used for dictating how severely we should be punishing the model for getting the wrong answer. And so there's also, of course, there's many options. If you look in the documentation, you have many different options for every little piece of the model and the whole process that we're going through. And then the optimizer, so we'll be using the adaptive momentum, which is ATOM for short. And of course, this one also has a lot of options in the documentation. And in our model's adjustable so it's going to take in the net, which is our model, and the parameters. And so what this is going to is just there are parameters that are going to be adjustable parameters. So these are the parameters that our model can change, that our optimizer can change when it's learning. And then also we have a learning rate that's suitable for the best outcome. What I'm trying to say here, it's like there's different types of rates, but I have seen that many people use the 0.001 just because we're trying to find like what the best value is going to be, and you don't want it to get all the way to like 0 right away because it's going to probably get stuck bouncing in a very strange manner. There might be a better animation that I can show for this situation. But we could visit this in the Q&A if you guys do have questions about this. And of course, if you take a look in the documentation, you can see loss functions and then also some optimizers that you can use. And the last step, which we said was train the model. So in this section, the model will go through 3 training sessions. Each training session will iterate through a batch from our train set, which we specified was 10. So you can see here, it's going to go through a range of 3. So it's going to be 3 training sessions. More, this number is pretty much just what I put in there because it does take some time. For the training session, we're going to iterate through a batch from our train set, which we specified was 10. So you can see for data in train set, so this is pretty much going to get our train set, which has many different batches. And so data is just going to be a batch of data. So X parameter will have the images, Y parameter will have the correct answer for that image. So the X value is going to be the images, and the Y is going to be our answer to those images. And that's going to be equal to our data, because data is pretty much has the images. It's a matrix or a tensor, and it has those 2 parameters. Net zero grad, this is going to set the gradients to 0, so the value doesn't get added into the lost values. So pretty much when we're going to be punishing it, these gradients are going to be used the gradients are going to be used to the model if it gets the wrong answer. And pretty much you want to zero it out, because if it already has a number in there and you calculate the loss value and also add those to the loss from the beforehand, it's just not going to do what you want it to do, because you want to punish it just enough for every iteration. You don't want to be adding on top of the value, but this is pretty much what we're going to be doing. All right, so our output, it will call forward from our model to return some values for each image. So this is where we call our function. So this is our model, and we did define forward. This was our function that we defined. That's going to be through all the layers. And the first layer that we said it was 784. That's how many parameters it's going to take. So we pass in X, and then we pretty much have to use view part of Pytorch and using tensors in order to parse this. Okay, so so it's going to be a matrix. It's going to have a batch of 10 images in there. -1 inside this view function, it's going to pretty much tell it that it's got multiple images in there. And -1 just stands for it can be any amount of images. And so how big are the images? They're 784. So there's 784 pixels, and -1 just stands for there's any number of images within that tensor. Okay, and then we calculate our loss using the loss function, which we did say it was cross entropy loss. It's going to set output, which is 10 parameters. We said it's 10 parameters after, so it's going to be able to tell us, oh, it's either a 1, 2, or 3, and this is for 10 different images. We're doing 10 at a time. So it's going to be 10 images, and then we can calculate that. So our Y is going to be our answer as we defined over here in our data. And our output is going to be our prediction. And if it guesses it wrong, it's going to go through the loss function, and it's going to pretty much come up with a value. And then we do loss.backward, and this is called backward propagation through our model. And this is pretty much gonna it's gonna punish it, and it's gonna pretty much adjust the values when it calculates when it's trying to learn like patterns within the data set that we gave it. And this function this Pytorch is really easy. You just pass in this right here, the backward function, and it does it automatically. You don't really have to do any coding when it comes to backward propagation when it comes to Pytorch. And then our optimizer.step, so our output, each image. Loss will be our values compared to our labels and use that. Oh, it's called back propagate, not backward propagation, through our model. And then finally, we use optimizer. And it's going to adjust the weights for our model. And that's like the parameters that we said it's going to be able to take, which are our net dot parameters. And these are pretty much our weights. These are the parameters that we're allowed to change with the optimizer. I guess you can call that a bias. That's another term that they use. Our weights are our biases. Same thing. And the step is just going to be able to apply that change in those weights after every forward pass. So this is going to be probably like, I believe it was like 16,000 iterations. So it does take a while for this to go through. If we had more ranges, it's going to be taking a lot longer. So this is where having a really good computer comes in handy. And well, if you followed along through this, which I don't assume you guys did because we did have some problems. But this is pretty much what the brain is. This is pretty much made the brain, or you made our neural net. And then lastly, what we could do is we can test it. So this will differ with other projects, but essentially what is happening is we grab a batch of test images and computes a prediction. Then we keep track of the amount of images and the number of correct guesses. And lastly, print the accuracy of our model, which isn't bad at all. Wait, I think we got a chat. Somebody's having audio issues. My bad. That might be on my side. I'm not sure. But this animation is exactly what is happening here. You can see the number correct. We have correct up here. We have total, and we have a total here as well. And pretty much this division takes place right here, the correct divided by total. And then it's pretty much gonna come out with the number of guesses it came out with their test data. So as I don't know if you guys remember from the first part, we did have two different types of data sets. We had one that was specifically for training and one that was specifically for testing. And it's gonna pretty much, this is where it's gonna be testing it. I don't, if you guys are familiar with Python, this might make a little sense. But essentially, we're grabbing the data from our data set, then we're passing in those 10 images within our net. It's going to give us an output, and then for our output, we're going to be testing it with our y, and then we're just pretty much going to be adding one to correct or one to total, and then we round the number, and it will give us an accuracy prediction, or it's going to give us the accuracy of how good our model was. All right, so Q&A. I can see myself in a third perspective, and I can see that this is a little too fast for the amount of information that we covered. This is a lot of information just thrown out, and I'm pretty sure I lost most of you because I would have lost myself if I was watching this. But I'm gonna be looking in the chat to see what you guys are saying. So is the test data set bigger or smaller than the teaching data set? I'm gonna guess like it could be whatever, but essentially when you separate it, one of them is going to be like different because let's say our training data was all categorized like in the same area. Like we have a matrix, and every time we pass it, like every number of time, like let's say we pass it 10 times, and on the 10th time, there's a 2 always on the second portion of that matrix. And so if we're always passing that in our training set, and it's always going to be a 2, it's going to think it's a 2 all the time, on that second portion of the 10th iteration. And so once we come to our test, if we pass it like 10 different ones and the test on the second one, it's not a 2 because it says our testing data is just random data, and like pretty much it's analyzing the information. And the model will probably think it's a 2, but it's not a 2 because uh, the model pretty much picked up on the pattern that on every 10th iteration, uh, they pretty much understand that there's going to be a 2 there, but it's not a 2 when you're actually testing it, which there's a lot that you have to go through when preparing your data, because you don't want the model to like pick up on random information that's not what you're going to be doing. All right, so but I think it was great because it shows me what Python is capable of. Food for thought, essentially. It shows all of this. Yeah, I know it was pretty fast, but I would say this is a complicated topic, and you would understand it a lot more if you are good with math, specifically derivatives. But like once you go through like I guess YouTube videos and they go over the math with you, it'll probably take some time, but you'll understand exactly what's going on, like because it has to deal with a lot with like with curves, uh, and certain values. So in our sources, uh, pretty much this is what I use. This is where the code comes from. I did change some things in our code because some things were not clearly defined in our code. But the first link will take you to the code that I used, and also has some YouTube videos that you can watch if you want to take this further. And also 3 blue, 1 brown. So what I really want to do is combine code with the YouTube video because the YouTube video has really good explanations with how the with how the neural net is working, how deep learning works. But they don't show any code. It's like how do I connect the 2 dots? How do I connect the code with the information presented in the video? And that was my goal in doing this presentation, is pretty much going over the code and then kind of having animations from 3 blue, 1 brown, to sort of clarify it. All right. So from your last answer, I take away it's more important that the test data is not the same as the teach data, regardless of the size. Uh, yeah, essentially, you pretty much do want it a lot of information. The more information you have, the better it's going to be able to learn. Um, the test data is just like when you're pretty much throwing it out in the real world and you're pretty much testing to see if it'll do what it's supposed to do. But training data, I guess you do want a lot of it, but you do want it to be random and not like have a specific pattern to it. But that's where I said in the first part where you prepare your data, it most of the time is just going to be preparing data, like whatever data you want it to be. It could be visual data, it could be whatever you want it to classify. Um, but there is different types. The very popular one for like vision. If you guys see my camera right now, I know somebody asked about what the red thing is. It's pretty much using it's using deep learning as well to track my face because it recognizes that my face is a face. So it puts a box around it. Um, I know some of you said it was distracting, but I should probably take it off maybe. Um, but that's essentially what it's doing. But this specific type for video cameras is called convolutional neural networks. And it's used specifically for videos because it like breaks it down into bigger chunks, so it's not like getting every little pixel of the image. It's more like taking a section of the camera and then comparing those however many sections you want to specify in the camera. So we'll say like 32 sections in this video, and it's going to be going through the neural or the convolutional neural network, and it's pretty much going to break down to see if my face is detected, and if it is, it's going to put a box around it so you can see it'll follow me. Can we please share the PowerPoint presentation? Yes, I can do that right now. What are some real-time applications of PyTorch? I would say the camera that I'm doing right now, like it could all like since we can also do the video portion, you can pretty much have a camera attached to the outside of your house. You can come up to the camera, and if it detects that it's your face, you can have something do where it like unlocks the door for you automatically, or opens the door because it recognizes your face. Um, but there's also other uh, ways that people would do it in video games. The Sentdex, this person right here, he's really good with deep learning, and he has a GTA, which is a video game, a first-person shooter, and he pretty much created an AI that can go around and interact with the world in the virtual GTA world and do uh, pretty much whatever it wants it to do. Am I planning on making a Discord server for the coding club? It's possible to make Discord bots, automated user accounts using Discord API that can do really cool things. I thought about it. I just figured maybe not a lot of people would be willing to join the Discord. I could probably, I'll get back to you on that one. I would actually really like to have a Discord server set up for the coding club. Um, I do have some servers, personal servers, and I do have them loaded up with bots, mainly for trading notifications, like using TradingView, and it'll pretty much send like links, so I can see when like Bitcoin is at a certain price, or Ethereum. Okay, so from Cubra, biometrics has some cool applications. What is biometrics? I'm guessing it's a website. All right, thank you, Alexander. I'll see if I can add you. But I will share the Google Docs in the chat right now, so you guys can check it out. Yeah, that could be a form of biometrics. I'm just not familiar with that word. I know bio means living, metrics has to do with data, but that word doesn't really is not really familiar with me, but it does do that. Let's see. I think I got this loaded up on here. So I can probably go through these examples. If you see current video on screen. Hopefully you guys can see what I'm doing, but this is in the live notebook that I had. Hopefully it'll work now, if it's not too slow. But so I'm getting ready for my test set and train set. So I do want to show you guys what it's capable of. So this is where we're going to be defining our model. Of course, it takes the 784, which is 784 pixels, and then it's going to output 32 values, whatever the model wants it to be. So this is going to define our class, and we're going to initialize it, set up our loss function, and our optimizer. And so this is, and then finally we're going to be doing our session. So this is where it's going to be training on the training data. And essentially loss, you want this parameter to be low, and it should, while it's going through these, while it's going through the data, it's going to be able to give you a certain number. So you do want this number to be really low, because the lower it is, it means there's not that much of a loss. You didn't predict the images wrong. So you can see it goes from point A to 0.1270, and then I guess our third iteration would be lower, and it is 9.76. And so now if we try to get our accuracy of the information, this is going to go through it, and so to understand this. So our accuracy is 9. So pretty much we almost got 100%. It got 90% of the images right in our test set. Someone says they can't get into the link. Is anybody else having trouble with accessing the presentation? Because I do have it set for. Hold up, I haven't. Here, try that. If you still have. Okay, but I did want to fix something in this situation. So we did get an accuracy of 0.9, which is really good. It got 90% of, right, access to 9. I'll fix that again. But I want to show you guys this real quick. So in our model, we did say that it's going to output 32 parameters. But what would happen if we gave it more? So instead of 32, we'll just say a number, we'll say 128. It's going to output 128 parameters. So it's pretty much going to give output more things to recognize. We'll do 128 for the input because we're outputting 128. And I guess we can also do 1 here. And also 128 for our last one. So we'll run this portion, run that, and then we're going to train it. Train it with 100 parameters. For every hidden layer, it's going to be outputting 128, and our final one is going to have 10. So it's going to go through that. I'll check. Still denied. So somebody says that theirs is working after they refreshed. David, is it working for you now, by any chance? Awesome. All right. So that's a link to the Google slide if you guys want to check it out. There is links in there so you guys can see. I'm getting for the notebook, Kira. I'll check that out. Okay. If you guys, hopefully you guys are seeing my screen right now, my shared screen. I hope it's not too bad, but it did finish up training with 128 parameters, and as you can see, these values are a lot smaller. It didn't seem to like have like a bad time towards the end. But now we're going to be testing the accuracy. So remember our last one got 90% of them correct, and if we run this one, that's I don't think it should be 1. Okay, that's a bit strange. But it's like 90. It should have been like a 95.8. I believe that's the most I've ever had. So I might have done something wrong when I get 100%. When it's 100%, it's you wouldn't want to trust. You don't want to trust it. Yeah, because yeah, 1 is 2. It's too perfect, and that's usually not what happens. Okay, so Kira, in the notepad, try executing each line. And we should definitely make a coding club Discord. I can probably do that. We get like 4 minutes. I guess that's our final present. That's the final. I know things, of course, never seem to go right, but and the information was very quickly handed to you. Except you guys could, if you guys are interested in learning more about this, you guys could go into the sources. I'm gonna see if I can make a Discord channel. And if you have any questions, you guys can ask in the Discord channel.